Hello, this is Mr. Kinyanola, and I'm going to show you how to figure out the area of this 1, 2, 3, 4, 5, 6, 7 heptagon. So how many squares fit inside of this heptagon when every side is 8 feet? So let's put an 8 in there. It's regular, so all these sides are 8. So before we start calculating some stuff, we have to remember a few things. First thing is that's the area of a triangle. The area of a triangle is equal to base times height divided by 2. Remember, we divide by 2 because a triangle is half of a rectangle. And the next few things that we'll need or may need are sine. The sine is the opposite, and let's put theta of the angle over the hypotenuse, or the sine opposite hypotenuse. We need to remember cosine. Theta, remember theta is the angle, is the adjacent over the hypotenuse. And we need to remember tangent theta, which is the opposite over the adjacent. The oa, the toa, the ka, and the so. Okay, so we may need to use any one of those three, but for sure we're going to use area of a triangle. So why triangle with a heptagon? Well, if you watch the previous video on how to find the area of a hexagon, then you'll know. So I'm going to estimate where the center of this heptagon is, and I'm going to say right here, and I'm going to draw a triangle. Okay, and this one triangle represents 7 congruent triangles. We can draw 7 triangles here, and if we found the area of this one triangle, we can multiply that by 7 and get the area of this entire heptagon. So let's focus on this one triangle where its base is 8. And remember, the area formula, base times height. Remember, the base and the height have to be perpendicular, but here we don't have a 90-degree angle, so let's draw a 90-degree angle. I'm going to take my ruler and just draw a line that is perpendicular to this base, which is 8. Pretty close. Should have scooted over just a little, but it's not drawn to scale. So, and that means that this right here is 4. From here to here is 4, and from here to here is 4. And we're going to put a 90. Now, let's figure out what the measure of this angle is right here, this big angle. If we remember, and just to help you out, just to help you visualize, okay, let's draw those 7 other triangles. So here, 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 and here. And I want to know what the measure of this one angle, or each of these little angles are. Well, if we remember, all the way around is 360 degrees, and all 7 of these angles are congruent. So I'm going to take my calculator, and I'm going to take 360 and divide it by 7, and it might be a decimal. Yeah, 54 or 51.42. I'm going to estimate it to 51.43, and all these angles are 51.43 degrees. Yeah, so that means that this angle right here, this entire angle is 51.43, and I'm going to take this entire angle and divide it by 2, and it'll be 25.71. So I'm dividing by 2 because when this line, this perpendicular line, it bisected the 51.43 to make this 25.7. Okay. All right. So I think we have almost everything we need. Okay, so we drew our height, which is perpendicular to the base. We found this angle right here by splitting all 7 of these angles up. Okay, so splitting 360 by 7, and then bisecting it one more time. So this entire angle is 51.3, and this little angle right here is 25.7 plus 25.7. You would get 51.43. Okay, so what's our goal? Well, area of a triangle is base times height. We have the base, which is 8. We need to know what this height is right here. So I'm going to put an X right here. And we're going to focus on this one triangle right here. And this is a right triangle, conveniently. And so I want to find what this is. And we have this 25.7 and we have 4. And remember, we're only focusing on this triangle right here, this half triangle of this full triangle. And so this 25.7 and this 4, 25.7 and 4, this is the opposite. Okay, and then this x to the 25.7 is the adjacent. So we have the opposite and we have the adjacent. So what are we going to use over here? We have opposite, we have adjacent, so we're going to use tangent. And so let's set that up because we want to figure out what that height is. So we're going to write the tangent of 25.7 is equal to the opposite, which is 4, over its adjacent x, and we're going to put a 1 right under, and we're going to cross multiply. X times tangent of 25.7 is x times tangent of 25.7 equals 1 times 4 is 4, and we're going to divide both sides by tangent of 25.7 right there. And these cancel out, and x is equal to, and let's clear, make sure my calculator is in degrees, and it is in degrees, and I'm going to press 4 divided by tangent of 25.7, which is 8.311. So let's round that to 8.31. Okay, so our height is 8.31. All right, so now we can find the area of this entire triangle. And the area of that entire triangle, we're going to use area equals base times height divided by 2. So our base is, okay, so we want this entire triangle because remember we split it up to 7 equal ones. We don't want only half, we want this full triangle. So 8 times the height, which is 8.31, and divided by 2. So this right here represents the area of one triangle, but we want to get the area of this entire heptagon. And remember, we split up this heptagon into 7 congruent triangles. So I'm going to take this, which represents the area of one triangle, and I'm going to put a 7 right here because we're going to multiply that by 7 to get the full heptagon's area. So let's put this in our calculator. 8 times 8.31 and divide that by 2. And we're going to multiply that by 7. So this right here, this 33.24 represents the area of one of these triangles. So each of these triangles, but there's 7 of them, so we're going to multiply it by 7. And we will get 232.68. So 232.68, and what is this? This is in feet, so feet squared. All right, that is how you find the area of a regular heptagon. So you split it up. It's a heptagon, so there are 7 congruent triangles. We're going to focus on one triangle. We have the base. We need to find the height. We found this angle by dividing 360 divided by 7 and dividing it by 2 to get this half of 51.3. And then we use tangent to find the height. We multiply the base, which is 8, times the height, 8.31, divided by 2, which is the area of one triangle, and multiply it by 7 because there are 7 triangles that make up a heptagon. And there you go. Okay. All right, so now that you got that, hopefully you got that, let's do another example. So you know what's going on, so that you could practice your newfound skills. All right, so let's read this. The apothem. So that's an important word. A regular, not a octagon is 14 yards. Find the area. Okay, so apothem. Remember, apothem is not this right here. This is the side length. An apothem. So let's split up this octagon. Let's just split it up into the one triangle here and here, and so that we can focus on the one triangle. And so the apothem of this one triangle is 14, and so the apothem really is the height of one triangle. Okay, so let's just draw this, and hopefully that is perpendicular. It's perpendicular enough. So there, and this apothem is 14. Right, so remember our goal. Find the area of one triangle, then multiply it by 8 because it's an octagon, and you can, if you have 8 congruent triangles, you can make one full regular octagon. So we need to figure out the length of the base. But before we can find out the length of the base, we need to figure out the length of this angle. But before we can find the length of this angle, we need the length of this entire angle. So let's take 360, because remember 360 is all the way around. So I'm going to take 360 and divide it by 8, which is 45 degrees. And so so this entire angle is 45 degrees, but we want to work with this right triangle right here. So I'm going to take that 45 divided by 2, which is 22.5 degrees. So I'm going to take a different color and write 22.5 degrees right there. Okay, so this angle is 22.5. This is also a right triangle, and we want to figure out, so if we focus on this, we can figure out the length of this. I'm going to put x right here. Okay, and we have the opposite, and we have adjacent. So again, just like in the previous problem, we can use tangent because we have this angle, theta, which is 22.5. We have the opposite, which is x, and we have the adjacent, which is 14. So let's write tangent of 22.5 is equal to the opposite, which is x, over 14, which is apothem. And we'll put a 1 under, and we'll cross multiply. 1 times x is just x, is equal to 14 times tangent of 22.5. And then I'm going to take my calculator. Calculators are so great. 14 times tangent of 22.5, which is approximately 5.8. Okay, so this is 5.8, and so that means that, and let's focus on this, so that means that this is also 5.8 because this line, this perpendicular line, which is the apothem of the octagon, bisects this base, so both of these are congruent. So the length of this entire thing, 5.8 times 2, is 11.6. So 11.6 is our base for our triangle. The 14 is the height. So let's set that up. So I'm going to write base 11.6. Remember, the entire base times the height, which is 14, and divided by 2 because this is a triangle. Okay, so a lot of students that I see, they'll take 5.8, multiply it by 14, and then divide it by 2. That's only finding the area of this half of this full triangle. So take the full base, 11.6, times the height, which is 14, and divide it by 2. And remember, this represents the area of this one triangle, and we're going to multiply it by, it's an octagon, so 8 congruent triangles fit inside 8. And then let's grab our trusty calculator, and let's type in 11.6 times 14 divided by 2, which is 81.2, which is the area of one triangle, but we want to get all 8 of them to get the full area of the octagon, which is 649.6 yards squared. So that's how many square yards, or yards squared, squares fit inside of this octagon when the apothem is 14. All right. Okay. Now here is our last example. If you want to press pause and try to do this on your own, the radius of a regular decagon is 18. Find the area. Okay, so I always just take that bottom one. Oh, and that is incorrect because that's not 18. Radius of a decagon is 18. So I'm going to estimate where the center is at. And I'm going to focus on that. Oh. Excuse me. Oh. It is allergy season. All right, so this is actually the radius right here, where the center meets a vertex. So this will be 18. We don't know if this is 18 or not, but we know for sure this is 18 because it says the radius is 18. And I'm going to draw another one to make our full triangle, which is 18. And I'm going to draw my height, which is also known as the apothem. So from here to here. And that should be perpendicular, even though it doesn't look exactly perpendicular, but we'll live with it. Okay. And so, this is a tricky one because we don't have, if we focus on this one triangle and we want to find the area of this one triangle, we don't have the base. We don't have the height. We only have the hypotenuse. So we need to find both of these. So let's figure out what this entire angle is. We're going to take 360. And because this is a decagon, 10 congruent triangles make a decagon, so I divide that by 10, which is 36. But we want to focus on this half, this right triangle right here. So 36 divided by 2 is 18. Oh, what a coincidence. This is 18 degrees and these sides are 18. Okay, hopefully that doesn't confuse you. Okay, it's not, these won't always be the same number. Okay, this is 18 degrees, the angle, and this hypotenuse is 18. And we want to figure out, let's start off with figuring out what the apothem is, or the height. So this is the adjacent. So if we focus on this one triangle, okay, so don't look at the other triangle. So just focus on this one triangle. 18 degrees, this 18 is the adjacent. This 18 is the hypotenuse, adjacent hypotenuse. So we're going to use cosine. Remember, cosine is adjacent over hypotenuse. So cosine of 18 is equal to the adjacent over the hypotenuse. Put a 1 under, and we'll just cross multiply. So 1 times x is x. And 18 times cosine of 18, so x is about 18 cosine of 18, 17.12. So I'm just going to round it to the nearest hundredth, so 17.12. So our apothem, 17.12. We have our height. Let's figure out what this base is right here. Okay, so we have some options. I'm going to call this y. And I'm still going to use this 18, even if, but you can still use, you can use this adjacent if you want, but I'm going to use this y and 18. All right, and so let me grab another color. And so we have 18, we have the opposite of 18 is y, and here's the hypotenuse. Remember, we're focusing on this one triangle right here, and this is the hypotenuse. So opposite over hypotenuse would be sine, sine of 18 is equal to y over 18. Okay, remember, these numbers won't always be the same. It's just a coincidence. And we'll cross multiply. 1 times y is equal to 18 times sine of 18. And 18 times sine of 18 is approximately 5.5 5.56. So this is 5.56 and this is 5.56. What is this? Inches? Yeah, 18 inches. So this is 5.56 inches. This is okay. I switched those. 5.56. Okay, so now we have everything to find the area of this one triangle, which is our base, which is 2 of these 5.56. Remember, we want this entire base. So what we're going to do is take 5.56, multiply that by 2, which is 11.12, which is the length of this entire base. And then we're going to multiply that by the height, which is 17.12, and then divide that by 2. And this will give us the area of this entire triangle. And because it is a decagon, there will be 10 congruent triangles if we start off from the center. So we're going to multiply that by 10 at the end. So, and this will give us our final answer. All right, so we already have 11.12 times 17.12. We're going to divide that by 2 and then multiply that by 10 to get the area of all 10 triangles combined that make a decagon. We would get 951.872 inches squared. All right, so that is how you find the area of any regular polygon. Find the area of one triangle, use sine, cosine, and tangent to find the base and the height, or whichever one you're missing, and then multiply it by the number of triangles that fit inside. All right, there you go. Have a great day.